If you deploy a new version of your app and all pods disappear at once, you just cause downtime. Users see errors, request fails, monitoring turns red, and you say, but Kubernetes handles rolling update automatically. Well, it does, but only if you configure it correctly. Hi, I'm Shivam, and this is the fourth video of the series Kubernetes Production Survival Guide. Today, I'm going to show you how Kubernetes updates your application without downtime and how one wrong setting can silently break production. Till now in this series, we have covered Readiness Pro and Liveliness Pro. Now, we are stepping into something more powerful, and that is deployment strategy. When you push a new version of your app, how does Kubernetes replace the old pods? Let's see this in action. So here is my cluster. I have one control plane node and two worker nodes. Let's go ahead and we'll create a deployment first for our demo. I have already written a deployment file. Let me copy it and we'll go over it one by one. We can clearly see the kind is deployment. The name of the deployment is rolling demo. It has 4 replicas. It is running an Nginx 1.25 image. The container is running on port 80. And this is the command by which we are going to demo our rolling update. So currently, when I deploy this application, we should see version 1 on the output terminal. It will sleep for 15 seconds and then it will continue printing this. Now, if you look here closely, I have defined a strategy here. The type of the strategy is rolling update, and the strategy itself has two parameters defined. One is max unavailable, which is 25%. This means that out of these 4 replicas, only 25% of the pods can be unavailable at a given time, which means only one pod can be made unavailable out of these 4 pods. And this maxSurge equal to 25% means how many extra pods can be created above the desired replica count, which is 4. This also means that at most one extra pod can be created temporarily. Now let's go ahead and we will apply this deployment. Our deployment is created. We will create a service for this so that we can access this application from another terminal. So I'm trying to expose our deployment which is running on port 80 and the service itself is running on port 80. Let's go ahead and we'll do a port forward for this service so that we can access it into another terminal. So the port forwarding is done. Let me open another terminal and we'll do a curl on localhost here. So we can see our version 1 is getting printed here. As of now, everything looks fine. Now let's go ahead and we will update the deployment to version 2. I will make the changes in the argument. I made it to version 2. I'm going to save it and I'm going to reapply it. But before I reapply, I'm going to run a command to simulate live user traffic. So our deployment has been replaced. So our port forward is running and we can clearly see that on the second terminal where I ran this command, we can see version 2 over here. This is zero downtime. It works because we have replicas, we have limited max unavailable, and we have allowed maxSurge. If our replica count was 1 instead of 4, rolling update cannot protect you. If max unavailable is too high, you kill too many pods at once. For example, in our deployment, our max unavailable was declared as 25%, which stated that only one pod out of the 4 replicas can be taken down at a given single time. That is controlled deployment. Now let's try to break it intentionally. I will update the max unavailable to 100% and I will reduce the maxSurge to 0 so that we can see how dangerous this configuration can be. I'm going to stop this and I'm going to update our deployment. So first of all, I'm going to update the version to 3. I will make maxSurge as 0% and I will make maxUnavailable as 100%. So what this means is the moment I apply this deployment, all 4 replicas will be taken down at once. Let me save this and we'll replace our current deployment with this new one. So let me divide my screen into 2 so that I can demonstrate you the pod creation and termination live. So here I'm running kubectl get pods -w command, which will give the current status of the pod in real time. So as of now, we have we have 4 pods running with version 2. Now I'm gonna replace our deployment with version 3 and we'll see it in action. You see here, all our pods got terminated at once and all 4 pods were getting created at once and all our 4 pods started running at the same time. This is what we call it as downtime. If you look at this tab where I was running this command, we got failed printed here because all our 4 of the running pods were terminated at once. And only when all the pods were up and running, version 3 starts to get printed. But before that, we got failed. So this clearly simulates production outage. Kubernetes didn't fail here. We misconfigured it. So to recap, safe config is when you allow max unavailable to be 25%. That's gradual replacement. Traffic is always served and users never see downtime. But if we configure max unavailable as 100%, then users will see downtime. This clearly proves that Kubernetes is powerful, but it does exactly what you tell it. Zero downtime is not magic, it's math plus configuration. So, in real production, traffic never stops. Deployment happens daily, and you cannot schedule downtime in every release. Rolling updates allows you, first, blue-green type of deployment. Second, gradual replacement. And lastly, safe deployment, which is critical to production. And all the above combined with readiness and liveliness probe along with multiple replicas creates a resilient system. So now you have seen something powerful. Kubernetes doesn't just run containers. It replaces them carefully, gradually, and without users noticing. If you configure it properly, you can deploy your new app version in the middle of peak traffic and nobody will know. This is production grade deployment. But let me ask you something. What if the new version which you just deployed is broken? What if it crashes under real traffic? Rolling updates will never save you from bad code. In production, mistakes happens. Sometimes bad image get pushed or wrong environment variable slip in and suddenly the new version is causing errors. Trust me, as a senior DevOps engineer at a leading bank, I have seen this happen more times than I did like to admit. Bad image gets pushed to production, nobody notices at first. Then, when the traffic hits, error starts increasing. And within minutes, the entire application has to be rolled back. That moment is stressful because production doesn't wait for you to debug it calmly. So now, the real question is, when things go wrong, how fast can you recover it? In the next video, I will show you how Kubernetes keeps a history of your deployments and how you can roll back to a previous version in seconds. No panic, no stress, and no manual redeploy. Just one command, and that's it. That's when you will stop fearing the deployments. I hope you will take something meaningful out of this video. I will see you in the next one. Till then, keep learning.